2, Chapter 11, Section 4, Arithmetic Series. What we're going to learn in this section is to write and evaluate arithmetic series and to use a summation notation. Okay, some of the new words, what we know about series, arithmetic series, and we're going to talk about limits. So what is a series? A series is the expression for the sum of the terms in a sequence. Finite series and series have terms that you can count individually from 1 to a final whole number n. Infinite sequences and series continue without end. You indicate an infinite sequence or series with ellipsis points. That's the ... ellipsis points. So here's a finite sequence and a finite series. So you notice the only thing difference is the series is you had to put a plus sign in between. Infinite sequence with the ellipsis points, and an infinite series with the plus signs and the ellipsis points. Okay. So writing and evaluating a series. Use the finite sequence 2, 11, 20, 29, 38, and 47 to write the related series, and then evaluate it. So evaluate means just equal it, solve it. So the related series is the exact same numbers. You just put a bunch of plus signs in between them and set it equal. And that's how you evaluate. You add the sequence. So the sum of the terms of this sequence is 147. So write the related series for a finite sequence and then evaluate the series. So it gave us 0.3, 0.6, 0.9, 1.2, 1.5, 1.9, 2.1, 2.4, 2.7, 3.0. So we just rewrote all that with plus signs and then we added it up and we get 16.6. So 1B, same concept. Write the series for the finite sequence and then evaluate. You're just going to put plus signs in between and set it equal. So when you add them up, 100 plus 125 plus 150 plus 175 plus 200 plus 225, you get 975. Okay, pretty simple. So an arithmetic series is a series whose terms form an arithmetic sequence. When a sequence has many terms, or when you know only the first and last terms of the sequence, you can use a formula to evaluate the related series quickly. So here is the property, the sum of a finite arithmetic series. So S of n, the sum of a finite arithmetic series, A1 ... all the way to AN, is nothing more than the sum of n is equal to n over 2 times the first term and the nth term. So for arithmetic, so there's a common difference. So that's pretty good. So you can use summation symbol that looks like a little sum sign to write a series. And you can use limits to indicate how many terms you're adding. Limits are the least and greatest integral value of n. So here we go. The upper limit's the top number. That's the greatest value. The lower limit's the lowest number of n. And then inside the sum sign, you use the explicit formula. So the sigma sign is our equivalent for sum. Okay, pretty simple. So use summation notation to write the series 3 plus 6 plus 9 ... to 33 terms. Okay, so first thing we got to do is got to get an explicit form. So A of 1 equals 3. Do we see a common difference? 6 minus 3 is 3, 9 minus 6 is 3. So our D value is 3. So we got to write the explicit formula. Okay, so A sub n equals A1 plus D of n equals 3 plus 3 times n minus 1. So let's go ahead and simplify this. So this is going to be 3 plus 3n minus 3. So the 3's are going to cancel. So our A of n is nothing more than 3n. So this is our explicit sequence, our explicit formula. So we're going to go, well, n equals 1, sum all the way to the 33rd term, 33. and the explicit formula is 3n. Okay, so that's how we'd set that up. N equals 1 to 33 in our explicit formula. So if we wanted to solve this, what's our a of 1? 3. What's our a of 33? 99. So the sum to 33 would be 33 over 2 times 3 plus 99. So that's going to equal 33 over 2 times 102. So we can rewrite that as 33 times 51, and we can solve that. Okay, that's asking a little bit more detail. And then 33 times 51, you can get our handy dandy calculator out if you want. 33 times 51, 1683. So the sum of 33 is 1683. So we got our summation notation right there, and we got our sum. Alright, so 3a. Use summation notation to write the series for this for a specific number of terms. So a of 1 is 1. Looks like our common difference is 1. So a of n is going to be a of 1 plus d times n minus 1. So that's going to be 1 plus 1 times n minus 1. So a of n is just going to be n. So the summation is n equals 1 to the 6th term of n. Okay. All right, here we go. Next one. Use the summation notation to write the series for the specified numbers of terms. Again, if you're looking at your notes, it should have been 3, 8, 13, 18. So find our explicit formula. So our a of 1 equals 3. Our common difference between all these terms is 5. So a of n is a of 1 plus d times n minus 1. So a of n is 3 plus 5 times n minus 1. So distribute it. So a of n equals 3 plus 5n minus 5. So a of n equals 5n minus 2. So there is our explicit formula. So now we're just going to put the sigma n equals 1 to 9 of 5n minus 2. Okay, so to expand this series from summation notation, you could substitute each value of n to the explicit formula and add the results. Okay, to use the series n equals 1 to 3, you could find the number of terms in the sequence. So the values of n are 1, 2, and 3. There are 3 terms. So let's do it when n equals 1, n equals 2, and n equals 3. So that's going to be 5 plus 1. It's going to be 5 times 2 plus 1. That one's going to be 5 times 3 plus 1. So those equal 6, 11, and 16. Okay, so we could add those right there. So that's going to be a total of 33. Now let's go back to our s of n function and see if we can do it. So s of 3 equals 3 over 2 times, remember it's n over 2, a1 plus an. a1 is 6, and an, or for 3, is 16. So s of 3 equals 3 over 2 times 22. Okay, so s of 3 equals 66 over 2, which is 33. So it works out. So you can evaluate the series one at a time, or you can use your arithmetic series formula to add a finite series. All right. For the sum, find the numbers of the terms, the first term and the last term, and then evaluate the series. Okay? So here's what we're going to do. Well, when n equals 1, so a of 1, that's going to be negative 2. And the a of 10 would be 10 minus 3 would be 7. So the summation notation would be this. We're going to 10, right? So that's going to be 10 over 2 times a1 plus a10. So S of n is going to be 10 over 2 is 5. Negative 2 times 7 or plus 7 is 5. So the sum notation is going to be 25. Let's see if that holds true. We could do old school way here and just double check our work. So when a equals 1, we're going to get negative 2. And when a equals 2, we're going to get negative 1. So it's going to work its way straight up incrementally by 1. So negative 2 and 1 are going to cancel out positive 2 and 1. 0 cancels itself out. 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 6 is 18. 18 plus 7 is 25. So it worked. Alright, next example. For the sum, find the number of terms, the first term, and the last term. Okay, well there's 4 terms. 1, 2, 3, 4. Okay, the first term, a of 1, is going to be 1/2 times 1 plus 1. So it's going to be, we'll say 3/2. The last term, a of 4, is going to be 1/2 times 4 plus 1, which is going to be 3. So the S of 4, the sum of 4 of them is going to be 4 over 2 times, we'll go ahead and say 3 plus 3/2. Alright, so S of 4 is going to be 2 times 3 plus 3/2 is 4.5. So the sum of those is going to be 9. So we can double check this pretty quick. Since there's only 4 terms, let's go ahead and do it. So the first term we got is 3/2. The last term we know is 3. So when n is 2, the answer is going to be 2. When n is 3, it's going to be 2.5. Let's go ahead and convert this one to 1.5. So you add these together, and what do you know? You get 9. So the summation notation works. Here we go. 4C. For the sum, find the number of terms, the first term and last term. Notice when n isn't 1, okay, that's not 1. All you do to find the number of terms you're evaluating is go upper limit minus lower limit plus 1. So my upper limit was 5, my lower limit's 2, so plus 1. So 5 minus 2 is 3, plus 1 is 4. So we're evaluating 4 terms. That matters. Now, since this is not a arithmetic series, is it? Okay, that's not a arithmetic series. That's a geometric series. We can't use the summation formula we did for arithmetic series. So we're just going to have to evaluate for n, and we're going to have to sum it up the old way. So when n equals 2, my answer is going to be 4 because we're just squaring our n value. When n equals 3, my answer is 9. When n equals 4, my answer is 16. And when n equals 5, it's going to be 25. So when we add these together, we're going to get 44. Okay, so again, it does matter how many terms we get. Upper limit minus lower limit plus 1. Okay, there's your homework. Good luck.